We present a fully automatic system that can produce high-fidelity, photorealistic 3D digital human characters with a commercial RGB-D selfie camera. The system only needs a user to take a short selfie RGB-D video while rotating his/her head to different sides. The total acquisition and process time with our system is less than 30 seconds. Our main contribution is a new facial geometry modeling and reflectance synthesis procedure that significantly improves the state-of-the-art. Given the user's input RGB-D selfie video, we first use a frame selection algorithm to select 4 frames covering different head poses. Then we perform geometry modeling using a newly constructed 3D and differentiable renderer-based fitting with the RGB-D data. Finally, a novel hybrid reflectance synthesis approach is applied to produce high-resolution albedo map and normal map with realistic details. Our frame selection algorithm consists of 2 stages. In the first stage, we perform a real-time landmark detection and then compute the rough head pose of each frame with a template 3D face model as reference for pose grouping. In the second stage, we first use image quality measurements to select the best frame in the front group. Then it is lifted to 3D and used as reference to compute accurate poses for rigidness verification. Finally, a best frame in each group is selected based on image quality ranking. After obtaining the best frame in each pose group, we perform an initial 3D shape fitting using the lifted 3D landmarks to extract texture maps from input photos, which are further blended into a full texture map. A parametric texture map is then estimated by performing a 3D fitting on the full texture map. With the initial 3D shape and texture parameters, we employ a differentiable renderer-based 3D optimization to model all available constraints including landmark loss, pixel-wise depth loss, pixel-wise photometric loss, and identity perceptual loss. As the constraints are abundant, the expressive capacities of the 3D shape basis become the bottleneck of the fitting process. We propose an effective approach that takes advantages of extensive data generation and perturbation to construct the 3D extending the source models from 200 to 100,000. With a novel stochastic iterative 3D construction algorithm, we are able to construct a 3D having much larger expressive capacity compared with previous methods. We show that even with the linear bases of the new 3D our method can consistently recover accurate, personalized facial geometry. For reflectance synthesis, we propose a hybrid approach that combines parametric fitting and CNN-based refinement models to synthesize high-resolution albedo and normal maps. The parametric fitting is based on a set of novel pyramid bases constructed by considering variations in multi-resolution albedo maps, as well as high-resolution normal maps. Faithful but over-smoothed high-resolution albedo and normal maps can be obtained in the fitting step. GAN-based networks are then employed to refine the albedo and normal maps to yield realistic details like eyebrow hair, lip wrinkles and facial skin pores. Please see our paper for more details. With the recovered facial geometry and reflectance, we further present a fully automatic pipeline to create a full head rig. Even with low-resolution selfie inputs, our system can produce high-fidelity, photorealistic 3D digital human characters, where eyebrow hair, lip wrinkles and facial skin pores are all clearly visible. Here is another example. Comparing to directly extracting texture maps from input photos, our synthesized texture maps are with much higher quality, especially when rendered with different lighting conditions. Our results are topological consistent and ready for animation. Compared with state-of-the-art single image-based 3D face reconstruction methods, our results are more faithful to input photos, with much higher quality realistic details. Here we demonstrate an application of lip sync animation of the created character.
我们这项技术可以通过手机自拍合成高保真数字人，整个过程只需要不到30秒。合成的数字人可以用我们的多模态合成技术进行驱动，给用户带来千人千面的数字人体验。
More results are as follows. Thank you for watching.